This video is on Venn diagrams. So a Venn diagram consists of a universal set, which we generally once again represent with the capital U, represented by a rectangle, and subsets within the universal set are generally represented by circles. We're just going to represent a few things that we've already looked at previously on Venn diagrams. First of all, the intersection of two sets. So if we have A is the first circle, B is the second circle, the intersection is the parts of the circles that are in both, which means it's the part where they overlap. So the intersection of two sets is that middle part there because that part is in both circles. Now the union of two sets, if we think back to once again our set lesson, the union is either in set A or set B or both. So on the diagram here, set A, set B or both means it could be in there because that's set A, it could be in here because that's set B, or it could be in the middle because that is both. So anything within the circles is classed as the union. Now A is a subset of B. Thinking back, subset is when all of one set is in another set. So what A is a subset of B, which is telling us that all of A is also in B, which means we would have a circle, which would be B. Now, if A is a subset of B, it means all of A is within B, so we would actually draw the circle of A inside the circle of B. And then disjoint or mutually exclusive, thinking back, it means that there are no elements in both A and B that are the same. There's no crossover, which means when we draw this, we will draw our circles separate, and there will be no crossover between our circles. And then on these two, if we were to colour it, so A is a subset of B, means we're looking at all of A there. If they're mutually exclusive, the circles are separate. Now, depending on the problem, each element can be also shown in a diagram, or the number of elements can be written, and through different examples, we'll see what I mean by that. So first example, let the universal set be this. Now think back to the interval notation. This means that x is an element of an integers such that x is between 0 and 10, including both. Then we also have set A, which is 2, 3, 5, 7, and set B, which is 1, 3, 6, 7, 8. Firstly, we're going to find the intersection and the union of these two sets. Then we're going to put it all on a Venn diagram. So first of all, we want, what is the intersection of these two sets? Remember, an intersection are the numbers that are in both, the elements that are in both sets. We'll look at A and B, or what numbers are common between both of them, and we will see that is 3 and 7. In part B, we want to find the union A or B. For this one, I always just like to look at the original universal set, which is everything between 0 and 10. Go through each number separately and have a look, is it in A or B? Starting at 0. 0 isn't there, so it's not in the union. 1 is, 2, 3. 4 is not in either, so we're not going to write that down. I can see 5, 6, 7, 8, 9 and 10 are not in either set, so we will not be including them. So that's our union, the numbers that are in A or B or both. Now we want to illustrate on a Venn diagram. So we're going to draw a nice big rectangle. With Venn diagrams, you have to draw a rectangle. You cannot just draw the circles. You have to have the rectangle there because the rectangle represents the universal set. And you'll often see the universal set written as a U on the outside there. If it's not there, you won't lose marks. Another way you could see the universal set written is like this weird E looking thing. And it looks a bit like this. That also represents the universal set, but U is the most common one that's used. Now here, A and B. Do we have an intersection? Yes, we do, which means we are going to draw them, these circles, so they overlap. Then we're going to start inputting the numbers. Now, when I'm drawing a Venn diagram, I like to start with the intersection and work my way out. So the intersection, remember, it's the part that overlaps. And our numbers that we have in the intersection are 3 and 7, which we found in part A. So they're going to go in the intersection because they're in both parts. We only want to put them once in a Venn diagram, so this is the way we do it. Now, we need to put the rest of the numbers. I'll have this side as A and this side as B. So in A, we've got the numbers 2, 3, 5, 7, if we look from the question. We've already got 3 and 7 there, so what's left in A is 2 and 5. Do the same thing with B. B is 1, 3, 6, 7, 8 from the question. We've already got 3 and 7, so we've just got 1, 6 and 8 left. But we also need to go back to our universal set, which is between 0 and 10. And the rest of our numbers get represented outside the circles but in the rectangle. So we haven't written 0 yet, so we can write 0. We don't have 4. We don't have 9 or 10. So they just get put in the rectangle but outside the circles, which is why that rectangle is really important. Next example, illustrate the following numbers on a Venn diagram. We've got to think about how are we going to label all these circles. You see on the outside I have got the R for real numbers. And if we think back to that special sets video and information, we know that all the other number sets are subsets of each other. The smallest number set is a natural number set, so that's going to be there. The next smallest set is integers, and then the next one is rational numbers. Now from here then we can put all these numbers in the diagram. Once again, let's start right in the middle. So which of these numbers are natural numbers? There is only one, which is 16, so that will go in the middle. Then I'm just going to circle around it because I've put it in there. The next circle then is integers. 16 is an integer, we've already got it in the circle. Even though it's a natural number, it's still in the circle of Z, so we have that already. I want to know which other numbers are integers. The only one we have is -2, that is the only other whole number. Outside there we've got rational numbers, so which of these can be written as a fraction, which would be 8.5. And then when we come to the actual decimal numbers, 7.1, 0.115 and √3, any decimal number that ends can be written as a fraction. So 7.1 can be written as a fraction and 0.115 because they are ending decimals. Square root of 3 is an infinite decimal number, which means the only one that can't come under is real, so it goes on the outside of the circles. So that's another way we can also draw Venn diagrams. Last little bit here is Venn diagram regions. On separate Venn diagrams, shade the appropriate areas. I've already got the Venn diagrams drawn here. Part A or B, but not both. We want to think about where is that on this diagram. So I want to shade A or B, but not both. So I want to shade A, which is this part here, or B, but not both, which means I cannot shade the intersection. So those two shaded parts are representing that situation. Part B will want A and the complement of B. So we want to look on this diagram, A and the complement of B. So when we have an intersection and, we can work through a Venn diagram, and if we say yes to both, we're going to shade it. So if I'm going to look at this part here. I'm just going to put a little shade in it to start with. So this part of the Venn diagram, is it A? No, it's not, so it's not going to be shaded. This bit here in the intersection, is it A? Yes, because it's in the circle of A. Is it not B? No, it's not, because that part is also in B, so it's not the complement of B, so it can't be shaded. This bit here, is it A? Yes. Is it not B? Yes, that is not in B. So because we said yes to both, we shade it in. Then the outside, is it A? Nope. As soon as I say no, I can't shade it in. So that's the best way sometimes to approach these shading, is go through each section and ask yourself the question with what you're looking to shade. Now we're going to look at numbers in regions. So a lot of Venn diagram problems, we are only interested in the number of elements in a region, not what the actual numbers are. But this first example, how many elements are there in A? Then we're going to look at complement of B and A or B. So this Venn diagram here, the 12, 5 and 8 and the 6 are actually showed us how many elements are in that section of the Venn diagram. How many elements are there in A? In A we have this full circle here. And for how many elements are in A, we want to add the 12 to the 5 because there's 12 in just A. There's also 5 in the intersection, which are also in A, so that would be 17. The next part, how many are in not B? So once again, I'm just going to circle B because we want everything that's not in B. We know to look for everything outside of the B circle, which is the 12 and the 6, which would give us 18. The next one, A or B, which means A or B or both, remember. So it would be an A or B. So everything that's in those circles, which will be the 12 plus the 5 plus the 8, which equals 25. Part D, how many in A but not B? A but not B would just be the 12. B but not A would be everything that's just in B, which would be 8. Neither A nor B, so it can't be an A or B, which means it has to be the number on the outside, which is 6. Next example, given the number in the universal set is 25, we have 10 in P, 12 in Q, and 3 in P and Q. Find P or Q, or the number in P but not Q. So what I will always do in these situations is draw a quick Venn diagram, because I find this easier to help me work out where everything is. So now I've got U on the outside, which is equal to 25. In the intersection, if I can start in the middle, I will, is 3. Now in Q I have 12, but that is in the whole circle of Q, which means I must only have 9 there. Because the whole of Q adds up to 12, I've already got 3 in the intersection, so there's 9 left over. Then in P we have 10. Once again, we've already got 3 in the intersection, which means there must be 7 left over, so the whole circle of P equals 10. And then the number in U is 25. If I add up my circles there, I have 19. So 9 plus 3 plus 7 is 19. So I have 6 left over, which means 6 will go on the outside. Now I can look at these questions to work out what's in each part. So how many are in P or Q? We know P or Q, P union Q, is all the circles, which is 7 plus 3 plus 9, which is 19. And then the number in P but not Q, so we want just P, which is 7. It's a number here that is only in the P circle. Example 3, suppose that the number in U, the universal set, equals 30, in A equals 13, B equals 15, and not A and not B equals 7. We want to find this information. I'm going to go draw a quick Venn diagram to help me with this. Now I'm going to show you how to do this a bit of a different way to help us work numbers out. And it depends on the information you've been given and how easy it is to figure out the other part. So in this one, we don't know the intersection. The really good one part of this diagram we do know is not A and not B is 7, and that's going to be the outside. We don't know the intersection, so I'm going to call that X. We know that the number in A is 13. So this has to be 13 minus X, because we know A is the whole circle, and this B part here is 15 minus X. So that's a way that we can represent our universal set, and we know all this ultimately has to add up to 30. So then to be able to work out different parts of this question, especially part A, we want to know how many is in the intersection. We're wanting to find out what X is. We also know every single number in this Venn diagram has to add up to 30, because that's our universal set. So for part A, we know that 30 has to equal 13 minus X plus 15 minus X plus 7. All the numbers have to add up to our universal set amount of 30. Then from here we can just solve that to work out what X is. So 13 plus 15 plus 7 will give us 35. Minus X plus X minus X will give us minus X. And if we rearrange this, we'll end up finding out that X equals 5. So the number in A intersection B, in A and B, equals 5. Then now we've done that, we can go back to our Venn diagram if we want to, and we can replace our X's with the 5, and we can complete this Venn diagram. So we know that's 5. A is 13 minus 5, which would be 8. and B is 15 minus 5, which is 10. And if you add all those numbers together, you'll get to 30. And now we can do part B, which is how many is in not A and B. So not in A would be this one and this one, but we want not A and B, so we are just going to be left with the 10. Okay, let's look at some problem solving. A really useful rule with Venn diagrams is this one. It's called the addition law. And you'll go more into it when you're actually going to year 11 and 12, but it's a really good one that can just help organise your Venn diagrams. And so it's the number in A or B, A union B, equals the number in A plus the number in B minus the intersection. Now the reason for it being like this is because if we think about it, if we have the number of A, we're going to go do this equation. So number of A would be everything in the A here, plus B, which is everything in this circle. But what you'll have noticed in the middle here is we have added the intersection twice. We have the intersection on the green and the intersection of the blue. We've counted those, the number in that section twice, which is why we have to minus one intersection value to make sure that then we only end up with adding this bit on here. And that's how this rule comes about. Now this rule, we can rearrange this rule so many different ways to be able to find out the different parts we may need to find depending on the information we're given. First example, there are 54 countries in Africa. English is spoken in 24 of them and French in 21 of them. Both languages are spoken in 4 countries. Put this information on a Venn diagram. All right, and now we've got English and French. I'm going to put them as E and F. So let's put this information in. So now both languages are spoken in 4 countries, so that 4 is going to be in the middle. English is spoken in 24. We've already got 4 included, so that would be 20. And French in 21, so there'll be 17 that speak only French. Now we've got to see, do those numbers add up to 54? No, they don't. They add up to 41, which means we have 13 left over. And there's our Venn diagram. Now, if we go to part B, in how many countries is English but not French spoken? Let's have a look. English but not French is just the 20. And part 2, neither language spoken, which would be the outside. So that would be 13. All right, next example. In a class of 35 students, 15 take biology, 15 take chemistry, and 18 take physics. 10 students take biology and chemistry, 7 take biology and physics, and 5 take chemistry and physics. 3 students take all 3 subjects. How many take none? Now here we've got 3 subjects we're looking at. And so something we can do is draw a Venn diagram with 3 circles. And with these circles, we're going to have one as biology, one as chemistry, and one as physics. Once again, if we can start in the center, start in the center. So how many take all 3? There's 3 students. So 3 will go in the middle. We know 5 take chemistry and physics. So chemistry and physics is 5, but we already have 3 there in this intersection. They also take chemistry and physics. They take biology too, but they do take chemistry and physics. It doesn't say chemistry and physics only. So because it says chemistry and physics, that whole little section there has to add to 5, so it's only going to be 2 in that part. We know 7 take biology and physics. We've already got the 3 included, which means that needs to be 4. And then we know 10 students take biology and chemistry. We've already got the 3, so that must be 7 to make that section add up to 10. Next, we know 18 students take physics. So the whole circle of physics has to add to 18. We already have a 4, 3 and 2, which is 9. So there's 9 left. 15 take chemistry. Once again, that whole circle of chemistry has to add to 15. We've already got 7, 3 and 2, which is 12. So we have 3 left over to make the 15. And then biology, we have 15 take biology. We already have 14 in the circle, which means there's only 1 that takes only biology. Now we have 35 students in total. If we add all that up, we actually find that that makes 29. So we have 6 students that don't take any of the subjects. So how many students take none of these subjects? That our answer to that would be 6 students. But once again, creating that Venn diagram, working out each section, makes that answer really simple to work out and find. And that is the end of the Venn diagram topic.